Hello everyone! Sorry, all you can see is my creepy hand. Okay, so this is how this will work. I'm going to break this into two videos. One of them will have kind of instructions about how this works and just your lecture. And then I'll have another separate video for examples so that you can just kind of stop and start and see how things work, okay? Sorry you have to look at my hands floating around on there, but that's all I've got right now. And so we're just going to go ahead and get started. Section 5.5 is about rational functions. Remember our rational function 1 over x that you memorized how it looked when we were flopping our arms? And we had to do a yoga pose to do this one. You had one in the first quadrant and the other one in the third quadrant. And so there were different things about this function that we needed to know. There is this thing called a horizontal asymptote where it is approaching this line. It just kind of gives it some guidance as it heads out to infinity. And in this case that would be 0 because it never crosses. And then there's a vertical asymptote also, and in this case it's also 0. Another line that it approaches but doesn't cross. In this case, it's the vertical asymptote is all about the denominator, and so we're going to see that later in how we find those. And then we'll always have 2 or 3 or more curves to them. Yours will all have 2 or 3 curves. But we also have x-intercepts and y-intercepts when the asymptotes aren't just at 0. I want to show you a couple of variations on this theme so that you have an idea in the back of your mind what we're going to be looking at, okay? Here's one that has one vertical asymptote over here and then a horizontal asymptote. I'll still make it at 0 this time, okay? Now this one might be that it goes on this side and then another one down this way. So still 2 curves because this graph has been cut once by this vertical asymptote. He's like a knife. He's cutting the asymptote. And so it cuts the curve and makes 2 curves out of it instead of just one. Still have a horizontal, but this time I have a y-intercept here that I could find. Okay? Let me give you another example. Sometimes there are 2 vertical asymptotes. That's 2 cuts in the graph. And so one of 2 things could happen. Let's make I still made a horizontal asymptote at 0. All's well. Horizontal's not always 0, by the way. So if I have a curve over here, I might also have a curve over here, and then what's going on in the middle here could take one of 2 forms, kind of 2 vague shapes that could happen here. One of them could be, it looks a little bit like a cubic function. Remember our x cubed has a propeller look to it? Then I have an x-intercept and a y-intercept, but I have 3 curves because I cut it twice with the asymptotes, okay? Or in the middle, you could have one other kind of shape. Maybe if I have 2 vertical asymptotes here, and you know what, just to mix things up, I'm going to put in a horizontal asymptote down here. Just for fun, it's good. So we may also have, instead of a propeller type look, an x cubed look to it, it might look more like x squared. It might look more like a parabola inside. And so if it does that, then the curves might be more out here, okay? Excuse me. Alright, so I have a y-intercept and 2 x-intercepts this time, and horizontal and vertical asymptotes. So we're looking at graphs that might have one of these forms to it. So that's what we're kind of looking at, okay? I'm sorry to cough at you. I think I've been talking too much today. Alright, vertical asymptotes. This is the value of x that makes the denominator 0. Guys, this is our domain. This is how we found domain before. We took the denominator and we set it equal to 0. Okay? And so that's what's going to happen here. If I look here, I notice that this would be 0 if x equals 2 or negative 2. These two are the vertical asymptotes. So this graph will look like one of these guys. Okay? This one, what values would make the denominator 0? It would be 0 for this one, or 5 for this factor. Okay? So these both have two vertical asymptotes. It's where the denominators equal 0. Alright. That's vertical. There's also horizontal asymptotes. Here we go. Alright, horizontal asymptotes are really describing what's happening at the ends. In the middle you have all the curves and all the things happening. It's shooting out to infinity. At the end, though, when it starts getting really big, it's going to approach a value, and so it looks like a horizontal line. This is all about what's happening here as x gets really, really large. So if the degree of the numerator is less than the degree of the denominator, then a certain thing happens. Let's look at the numerator. The degree of the numerator is 1. You see the 1 up there? The degree of the denominator is 2. So this one, the numerator is smaller than the denominator. When we're talking about x being 1,000,000, we don't really care about adding 3 to it. Or if we have 1,000,000 squared, subtracting 4 does not matter. So I'm only going to look at these leading terms. And I'm just going to simplify this rational function down to x over x squared. Well, that simplifies again. Do you see how I could knock out one of these x's? If I knock out an x, I get 1 and x. So, what happens when I have 1 over x and I'm heading out to infinity? If x gets really, really large, 1 over 100, 1 over 1,000, 1 over 1,000,000, your number gets really, really small. And so we say this approaches 0. So the horizontal asymptote is 0. Okay? The other case we're going to look at is when the degree of the numerator is equal to the degree of the denominator. Look at this. The degree here is 2. And if I multiply this together, the degree is 2, because this will be x squared minus 5x. If you're unsure about that, pause, multiply it out and see that, okay? So this is the same thing as saying x squared minus 1 over x squared minus 5x. When x is really, really big, I don't care about the rest of this stuff. I only care about the leading terms. I say they're what's driving the train, all right? So I have x squared over x squared. Don't care about the rest of that. Well, what's that going to simplify down to? They're both going to cancel out, right? And so the number out front is 1. Make sure you understand that that's what's going on. So the horizontal asymptote for this one is 1. This one is 0, and that happens every time that the numerator is smaller than the denominator. It goes to 0. Every time the degrees are the same, it goes to the coefficients. In this case, 1 over 1, because these are always going to cancel. There is one other case where the degree of the numerator is greater than the degree of the denominator. Here's the thing. We're not going to study this one, okay? It can happen, and it's called an oblique or slant asymptote. That means it's going to make some kind of a line or curve that's not horizontal, okay? So don't worry about that one. That's just a trivia, okay? Alright, the next thing is intercepts. The x-intercept is where y equals 0. The y-intercept is where x equals 0. Always, all the time, no matter what function we're looking at, okay? So let's look at this first one. The x-intercept is where y equals 0. So I put y equals, nice. If I want to solve this thing, I need to multiply both sides by the denominator so it will cancel out and go away. Boom, gone. 0 times that is still 0. Solve by subtracting 3. This is the x-intercept. The y-intercept is when x equals 0. So I go put 0 in for all the x's. So the numerator becomes 3, the denominator becomes -4. This is the y-intercept. It's where it crosses the y-axis. So this is where it'll hit the x-axis and where it'll hit the y-axis. Okay? Over here, let's do that again. This one is the x-intercept, is where y equals 0. Okay? So I multiply both sides by that denominator, make him go away. So on the left-hand side, 0 times anything is 0. On the right-hand side, cancel. I have x squared minus 1 equals 0. When you solve this one, you can add the 1 and take the square root, and you get plus or minus 1. Both, guys, both. All right, from the square root. Oh, I'm out of room. Here we go. Y-intercept is where x equals 0. So 0 squared minus 1. 0 times 0 minus 5. Let's simplify. The numerator becomes -1. The denominator is 0 times -5. 0 times -5 is 0. Ooh. Guess what that is? None. No, oh boy, not none. None. There are no y-intercepts because this is not a number. We can't do that. Okay, the whole world will explode. As bad as it is, we don't want it exploding. Alright, so no y-intercept. Alright, so putting all these ideas together is going to give us our graph. So we have lots and lots of things going on. But there's one other thing. Sometimes the graph has a hole in it. What? Let me show you what I mean. Let's say this one was coming along merrily, but it wanted to skip over this particular value. So it's called a hole. It's just going to have a hole there, an open circle, and the graph will go right up to it and skip over that number. A hole. So this one has a hole. It is when I have a common factor in the numerator and denominator, and then we're going to write its coordinates so we can graph it. Alright, so factors I need to find. That means I need to factor this numerator. Do you notice that it's difference of squares? The denominator's already factored. So, I see a common factor. I see that they both have x plus 1. So I take that x plus 1 and I find out what makes it 0. So subtract the 1 and it's -1. There is going to be a hole at -1. Okay? Now, the first thing we're going to do every time we graph one of these is we're going to factor the top and bottom, take that common factor, and cancel him out of there. So my new function is really x minus 1 over x. These guys are no good to us anymore. Cancel them out, steal the -1 for the whole, and this is my new function. I need coordinates where I'm going to plot this point. I'm going to put an open circle there. So I'm going to go put a -1 in for all the x's. Here we go. Try that again. -1 minus 1 over -1. Negative 1 minus 1 is negative 2. Over negative 1 is 2. Nice. The coordinate of the point is negative 1, 2. So we're going to go along on the graph and we're going to leave an open circle at negative 1, 2. That's a hole. Alright, the last little piece here that we have to put together is the domain. Remember, the domain for a rational function is for the denominator. It's where the denominator equals 0. So the vertical asymptote, or the hole, will cause a 0 in the denominator. So we're still doing the same thing, guys. We're going to look at the denominator and find out what makes it equal to 0. What numbers can x not equal? Well, 2 and negative 2. On this one, what numbers can x not equal? Well, 0 and negative 1. Okay? So your domain is all real numbers except those numbers that we found that would cause a problem. On the Pearson website, when you are typing in the domain, it wants you to type them this way. To that I say phooey, but I have no control over this, so it's going to ask you just to put x does not equal whatever numbers. So I wanted you to see that. You're not going to have to write it in interval notation on the Pearson website. So imagine when we do our test and when they do the final exam, it'll look like this. So you just type in those numbers, okay? Alright, let's put it all together. When you do the homework, it's going to say, follow the steps 1 through 8 to analyze the function. Just like last time, I don't want to do those steps all like that. I want you to do exactly what we just did. I want you to go find the horizontal and vertical asymptotes. So this is looking at the degrees, looking at the denominators. I want you to plot the x and y intercepts. This is where y equals 0, where x equals 0. We're going to go plot the holes if there is one. That's where you cancel out the common factor. And then you're going to need to plot some points. And we're just going to have to shortcut this a little bit, so I'll show that to you here in just a minute. But I want you to plot some points, and then we'll draw in the curves. You should be able to see where the curves go after that. Alright. I'm going to show you one of those from the example that we had. We were doing that same function over and over again. We did all the pieces for it. This one, okay? We found that it had a vertical asymptote at 2 and negative 2. Go back and look at your notes. That's what we just did. We found that it had a horizontal asymptote of 0. We found that it has an x-intercept at negative 3. And we found it had a y-intercept, there we go, at negative 3/4. Okay. We're also looked for a hole, but this one, when I factor it, this is difference of squares, right? When I factor it, there's no common factors, so no hole. Okay. For the domain, all the numbers are good except 2 and negative 2. So we just did all of that work. You've done all those pieces, so when I go to the graph, I'll go, let's go a little ways out here. I'm going to go to negative 2 and make a vertical asymptote. It's just an imaginary line, so I'm just going to dot it in. And another one at positive 2, a nice dotted line. The horizontal is at 0, so I put a nice dotted line to show it. The x-intercept is at 3, plot him in there. The y-intercept is at negative 3/4, so I plot him on there. No hole. Okay. Oh, I picked a really bad one for this. This one is really, really bad. Alright. That's what I get for not looking at it beforehand. So, Here's what's gonna happen. This thing, oh, let me show you on the calculator. I don't want you to, you are not going to have to do anything this nasty. I'm sorry. I really thought that I had a nice one for us. But no, I just noticed it. Alright, so I typed it into my calculator. Look at this thing. Ew, but you can kind of see what's happening. It does not type the vertical asymptotes or the horizontal. You have to know that they are there. Same thing with the holes. You won't see a hole on there. You have to know that it's there. It's too small. The pixels don't pick it up. Okay? But look at my curve over here. There's a funny thing that happens here. It crosses over and then it bounces back up. It does this funky thing. So, anyway, it's doing like this. And it's gross. Nobody likes that. Alright, it's coming down and bouncing off of it and coming back up. Alright, in here, closest count, I know that it's going to go this way. I also know there has to be a curve over here, and so I'm looking at my calculator and I can see that there's a curve over there, but it hugs the line so close that you can't see it. See how it looks like it just stops? It does not stop. There is no stopping, okay? So it's just hugging the line so close that you can't see it. Now what's so weird about this one that I didn't like? This thing right here. Usually this is not going to bounce around like that and cross the horizontal. Yours are all going to be clean and neat where I would have a curve here, and a curve here. Okay? Alright, so we go into our calculator and we type it in so that we can see where the curves are at. So we're going to shortcut that part of it. Usually I would make you plug in some values and plot some points, but we're not going to worry about it because we're kind of in emergency type learning right now. So, alright, I'm going to make another video that's going to have a couple of examples. You should go back and watch this again if you didn't write some things down. You should look at the examples that I did and make sure that you understand what was happening. But there'll be a second video right after this one that shows from beginning to end how to do a couple of these problems, okay? Alright, good luck guys. Use those graphing calculators. It'll help you out.